Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, and in this lesson we'll be going through our options in profile machining. In this part, I'd like to create a profile around the outside perimeter of this part itself. So I'll start with my profile operation. Now I'm going through right now basically all the options that we have in here. We start off with geometry. We have the option of choosing which Mac file we'll be working with, Mac position that we'll be working with, and over here we can now define our geometry. So we go into define geometry, and in this case I'm just going to take the bottom line over here, reverse my direction, and then use the option of auto constant Z to create my geometry. And that's done automatically. Now I can continue. The next thing I'd like to do is to choose a tool, and I'll create a new tool with a diameter of 16 millimeters, and I'll be using that for a rough cut. Also, I have my default tool data, and I can fill in whatever information I need over here. The next thing I'll do is I'll be choosing my levels. Now, in my levels area, I have my clearance level, which is taken automatically from the defaults that when I created my home position. The safety distance is taken also automatically from within the program. And now I have my upper level. My upper level will start from over there, and my profile depth will go to the bottom of the part itself. And if I want to go a little bit past the part, I'll simply say delta depth of minus 0.5 millimeters. Now we'll go into our technology area. In my technology area, we have our modify area, where I can say whether I want to work on the left side of my profile, of my geometry, or the right side, or the center. In this particular case, I'll leave it on left, which is the default, working on the left side of the line on the bottom. I can use compensation if I want, or work without compensation. The depth type, in this particular case we'll be using constant, but my options here I can either do define, where I can have different heights for each pass, or helical. We're actually going in a helical motion around the part itself. I'm going to use constant in this particular part. Now the depth cutting type, we have the option of either doing one way, we're going around and continuing going in the same direction, or zigzag, going back and forth. Since this is a closed geometry, a closed chain, and in any case I would prefer working now in one way, so I'll choose the option of one way. My next option is rest material chamfer, but since this is my first rough cut, we'll deal with this at a later stage. But this in general, what this will do, would allow me to actually deal with areas where the previous tool could not go into. In this particular case, I'll choose none. And now we have the option of use fillet size for last cut. If I were to activate it and say external, for example, any external corner that I have here, I can add a radius onto it, breaking the edge, say 0.2 millimeters. My other option for fillet size for last cut is internal. Now, what internal does is very simple. It doesn't mean if I put a radius here, I'll get that kind of radius on an internal diameter, the internal corner. That's obvious. What it means is as follows. If my tool radius is the same size as my radius over here, or larger especially when you have a sharp corner, so every tool is larger, it'll create the center tool path with a slight radius, thereby not putting extra pressure on this wall over here. So I can put, if I need, say 0.2 millimeters as well. We'll now move over to our right hand side of our screen. If I were to open my rough area, this will allow me to do a rough cut on my part, opening up my offsets. So I'll have a wall offset of 0.3 millimeters. I do not need a floor offset because my tool is going actually past the bottom of the part, so there's no really offset needed for the floor itself. Now I have here a step down of every 8 millimeters. If I were to change this to equal step down, then this will be maximum step down. What does equal step down do? We've gone through that in previous recordings, but just a quick recap, it will actually divide them into equal steps, having the maximum size of the step no more than 8 millimeters. In my next field, we have finish. If I want to do finish, I can do finish as well. And in finish, I have the number of passes I want to have as I go around the part, whether I have 1 pass or 2 passes. Extension overlap, whether I want to have an extension on the end of the tool pass itself to go past the start point. And we also have here maximum step down because this is set at equal step down, so we have the option of maximum step down. If I were to leave this at 0, it'll do it all in one shot. If I want, I can also make that 8 millimeters. But in this particular operation, I don't want to do finish. I just want to do a simple rough cut. So therefore, I will not use the option of finish. The clear offset option will allow us to clear off a step or an area if the entire tool was not big enough to clear off the area. In this particular case, I don't need it. And one more thing we have here is also complete Z level. This, if I had more than one chain in my geometry, I would be able to tell it first finish the Z levels on all of those chains and only then go to the next Z level. But I do not need it in this part. Now we'll go to link. In my link area, we have the option of ramping, whether we want to do it going down in a feed, rapid, or diagonal. If I were to choose feed, then when it goes down to my safety distance, from this point, it'll use the feed that was done in my tool definition for my Z feed. If I were to choose rapid, then it will go down past the safety distance in G0 in our rapid move, all the way down until our first step. And diagonal will actually go in on an angle up until the first level. In this particular case, I'll choose the option of feed. Now, we have our lead-ins, and our lead-ins we have either normal, coming in perpendicular to the surface, or we can choose the option of arc, coming in an arc, tangent, coming in tangent to the point, or picking a specific point. In this particular case, I like to approach with an arc of, say, 5 millimeters. Now, if I want my lead out to be the exact same as my lead in, simply click on the same as lead in button by the lead out, and I'll get the same values. If I want, I can always have something different, but I have all the exact same options that I have above. In this particular case, I'm just going to use same as lead in. When I'm finished, I have to do save and calculate. Now, after I do save and calculate, now I can run my simulation. And I like to do, in this particular case, the solid verify simulation. And you'll see that the tool goes around and mills out the entire part around. But you'll also note that these corners, because my tool was too big, are a little bigger than what they really should be. If I have to choose my option of 2D simulation, you'll see the exact shape of my geometry. And now, when I run my simulation, you'll see that the tool is going around. But if I would change the color, because as you can see this color is not exactly too clear, I can simply go into colors, change the color to a different color, just say OK, and now run my simulation, and we can see it now a lot better. Now you'll note in the simulation that my radius of the tool was bigger than the corner, leaving excess material. This concludes part 1 of our lesson on profile operations. Thank you for joining us on SolidCAMProfessor. Take care and have a nice day.